Okay, so planes in the unit cell. So that is, so the first step to draw the plane in the unit cell is to identify the points at which the plane intercepts the x, y, z coordinates in terms of the number of latest parameters, right? Remember that this term, this sentence in terms of the number of latest parameters, we are doing it for both directions and planes. So when we are drawing directions or planes, we are drawing it in terms of the magnitude is actually determined by the number of latest parameters. If the plane passes through the origin of the coordinate system must be moved. This was not the case in the direction. When we were drawing directions, we are not concerned with the origin. But here, the plane cannot pass through the origin. If it is passing through the origin, so you will have to move the origin from there, right? So remember this. The second step is take reciprocals of these intercepts. So you will have to take the reciprocals, right? The third is clear fractions but do not reduce to lowest integers. In directions, we were reducing it to lowest integers. We will not reduce it to lowest integers here, but we will clear fractions. And the last one is enclose the resulting numbers in parentheses. In directions, we were enclosing it in square brackets. Here, we will enclose it in parentheses. Remember that I have seen students making this mistake, particularly in exam when I ask them to draw the directions or to, I give them directions and ask them to write Miller indices for those directions. So what they do is they write the numbers correctly, the notation correctly, but they enclose it in parentheses. That is wrong. I usually cross it. I give them 0 marks for this, right? So you have to remember that when you're talking about plane, remember to enclose it in parentheses. If you're talking about direction, enclose it in square brackets. I cannot emphasize it enough. Again, negative numbers, same thing. Negative numbers should be written with a bar over the number, just like we did in directions. So okay, so let's see. This is a plane in the unit cell. So this is x, this is y, and this is z. If you look at this plane, so the first step is to do what? To find out the intercepts of the plane at the coordinate points of the okay. I don't know what is happening, but my system is lagging a bit. Okay, previous. So the first point is identify the points at which the plane intercepts the xyz coordinates. So we need to find out these intercepts. Now this plane is cutting the x-axis at half, right? This is full, so this is half. So intercept at half of a. This is a, from here to here, this is one latest parameter a, right? So this plane is cutting it in the middle. So we will say the intercept is at half a. Okay, it is cutting the y-axis at 1 or full a, right? So intercept here is 1. In terms of latest parameter, in terms of the multiple of a, so it is a, right, or 1. Clear? So 1. So at x-axis, it is in the middle, half, and on y-axis, it's cutting at 1. It's parallel to z-axis, which means that the intercept is at infinity. You must have read somewhere in your school that two parallel lines, the intersection of two parallel lines happens at infinity. So because they are parallel, z-axis and this plane is parallel, so it is infinity. The intersection is, or intercept is, at infinity. Now the second is, if the plane passes through the origin of the coordinate system must be moved. So, if you look at here, the plane does not pass through the origin. This is the origin, but the plane is not passing through it. So we do not need to move the origin from here. Okay, the second step is to take reciprocals of these intercepts. So reciprocals of these. So the reciprocal of 1 by 2 would be 2. The reciprocal of 1 by 1 is 1. And the reciprocal of infinity is actually what? 1 by infinity. So 1 by infinity is equal to 0, right? So let's go to previous. So we took the reciprocals. Third is clear fractions. We need to clear fractions, but do not reduce to lowest integers. So there are no fractions and it is in the least integer form. We cannot reduce it further. So 2, 1, 0. Okay. The fourth step is enclose the resulting numbers in parentheses, right? So what we would do is we would enclose it in parentheses, right? So the plane is 2, 1, 0. So the Euler index for this plane is 2, 1, 0. Okay, let's say if we want to draw a plane like this, this and this, this. Okay, so this is the intercept of the plane. I am talking about this plane. So let's find out the intercept. So it has an intercept on x-axis at a, right? So it is 1. Intercept at y is 1. Intercept at z is infinity because it's parallel to the z-axis. So take the reciprocal. So 1, 1, 0. Clear fractions. There are no fractions. Do not reduce it to lower integer. So keep it like this. And there is no bar or negative. So just enclose it in parentheses. So that is your 1, 1, 0 plane. Let's move forward. Okay. Okay, so now let's say we want to take this plane, right? This face of the cube, this one. Clear? Okay, so this is intercepting, this is parallel to x-axis, so this will be infinity. This is intercepting y at 1, so this will be 1. This is also parallel to z-axis, so this will also be infinity. So what you need to do is take reciprocals. So reciprocal of infinity is 0, 1, and 0. So 0, 1, 0. So that's your plane, right? Now the same families are found also in planes as well, right? There are similar equivalent planes. So when you have two zeros and a single one or unity in a plane, so it means that you're talking about the face of a cube. You're talking about the face of a cube, right? The plane is actually the face of a cube, whether it's this face or this front or this face or the top or the bottom or the back. So you will have this. For example, if you take this plane, the back one, right? The plane at the back side of this cube. So I'm talking about this one, right? So the problem here is that it is passing through the origin, right? So we cannot let the plane pass through the origin. So we have to move the origin, right? So we will move the origin in such a way that we get least number of negatives in the plane. So let's move the origin to from there to here, right? Why? Because I cannot move the origin here because it's also passing through the plane. Plane is also passing through this point. I cannot move it to here because the plane is also passing through here. So I am moving it here, right? So if you move the origin here, and so this is actually, this point is now -1. This is your 0, right? So the plane is intercepting x-axis at -1. So let's write it -1. Clear? Now, now this is your y. So if you look at this plane and this y, they are actually parallel. So it is infinity. And this plane is, now this is your z because you have moved the origin. So this plane is also parallel to z. So this is also infinity. So this will be, please take the reciprocal. So 1, 0, 0 plane. Now we have -1, so put a bar over here. So 1 bar, 0, 0. Clear? Okay. Now let's do this example. Determine the minor indices of planes A, B, and C in figure this, right? So let's take this A plane, right? So let's find out the intercept. So it's not passing. So let's say if this is our origin, which it is, it's not passing through the origin. So we are good here, right? So, for A, the intercept, it is, has intercept with x-axis at 1. So x-intercept is 1. Y-intercept is also 1. And z-intercept is so 1, right? So this plane is 1, 1, 1, right? Okay. Now let's talk about this, B plane, right? So what is B? So let's find out the intercept. So, this is the origin. B is also not passing through the origin, so we do not need to move the origin. So the intercept at x is 1. The intercept at y is not here, but here. So here y is 2. So let's take 2. And the intercept at z is infinity because it's parallel to z. So this is infinity. So the take reciprocals. So what will be the reciprocal of this? It will be 1. Reciprocal of this will be 1 by 2. And reciprocal of this will be 0. Right? Okay. So the next step is clear fractions. So we have to multiply it with 2. So if you multiply it with 2, so it will be 2. The second one will become 1. And this will become 0. And enclose it in parentheses. So 2, 1, 0. So this plane is 2, 1, 0. Okay. C plane. Look at this C. So C is actually this face. C is this face, right? So the first thing that we need to do is, because this face is actually, we have origin on this face, so we have to move the origin to here, right? So when you move the origin here, so this becomes your Z. This is our Y, and now this is your X. So for C, so now let's find out the intercepts. So it is parallel to x-axis because this is your plane and this is your x-axis. They are parallel, so this will be infinity. Y, so this is now your y is 1 here because you have moved the origin 1 lattice perimeter in the direction of y. So this will be your -1. So it is -1. And it is also, now this is your z and this is your plane, so they are parallel, so this is also infinity. So you need to take the reciprocals. So reciprocals are, okay, do you have sound problems? Okay, so take reciprocals of this. So the reciprocals would be 0, -1, 0. So in terms of minor indices, you will write it 0, 1 bar, 0. So this is your plane, right? Okay, moving to the next slide. So this is, 0, 1 bar, 0, 2, 1, 0, triple 1. So you can do it. It's a solved example. So you can do it from here. Okay. There is a relationship between planes and directions, right? Remember that a same index plane, right, is perpendicular to the same direction. For example, HKL direction HKL direction is perpendicular to HKL plane. Ji Aba Anas. Hello, Anas. Okay. So what does this mean? So it means that triple one plane, triple one direction will be perpendicular to triple one plane. So same indices. If you have triple one plane and triple one direction and triple one plane, so they will be perpendicular to each other. Same goes for all, right? For example, if you have 1, 0, 0 direction, it will be perpendicular to 1, 0, 0 plane. Zubair, please shut off your camera, please. And secondly, whoever is drawing these arrows is highly unwelcome. Please stop doing it. Okay. So, so this is the concept that you need to remember, right? Same indices direction is perpendicular to same indices plane. So if you look at this figure, uh, if you look at this figure, so the plane is, this plane is 210, right? We did that in the last slide. right? So this is the plane 210. So if you draw a 210 direction, so it will be this direction, right? You know, it is intercepting, the head is actually, this is what point? This is actually 1 half 0, right? And this 0 0 0. So if you determine the Euler indices this direction, so this will be what? They say that subtract the tail from the head, so subtracting 0 0 0 from this will be 1, the same, it will remain the same thing. So multiply it with the clear fractions, so multiply it with 2, so it will be 2 1 0, and enclose it in square brackets. So see, 210 plane direction is perpendicular to 210 plane, right? So this property holds for all such instances. Okay, now how do you find out the now this is actually, they're talking about the family of planes, right? So all the face planes are actually belongs to the same family, clear? But remember that these, the plane and its multiple are not the same. Why? Because you know, if you have atom here, like suppose it's a BCC unit cell, right? So you will find atoms here and one atom in the middle of this. So if you take this plane, you will find 4 atoms on the edges of this plane. You will find the same here, but this is different. You will only find 1 atom in the center. Well, I am recording this lecture, so I will upload it, right? If you have any question, you can ask after the lecture. So please stop writing on the screen. So the concept here is that a plane and its multiple are not equivalent. Clear? Right? They are not same. Why? Because the population of atom will be different. Okay. Now, if you look at this, so we have 2 triple one planes here. One is this plane, and the other is this plane. Right? Clear? So let's go to the software so that you can see how you have 2 triple one parallel planes, right? So let's end this slideshow. Let's keep all this. Okay. Let me. Okay. Do you listen to me? Please confirm in chat. Okay. Okay. So let me show you the. Uh, the planes, right? So let's remove these vectors first. Uh, okay, and let's okay, so now this is our face center cube. Let's draw some planes. So this is lattice planes. So new. Okay, you can see 100, right? So this is your 100. Clear? Remove this writing from the screen, please. Whoever is doing this, please remove it. Okay, so this is a 100 plane, right? This is your origin, and it is intercepting x at 1. And who is doing this? Who is populating the screen? Okay, so this is 100 plane. Well, I'm going to report the whole class to Sir Noor Saab because this is being recorded, and I'm going to put you into investigation because okay, so this is 100 plane. This is your origin. This is intercepting x at 1, and it's parallel to both y-axis and z-axis. Clear? So this is how it looks. For example, if you draw 111 plane, right? So it looks like this, right? It's a 111 plane. This is your origin, right? And this is your 111 plane. It's actually a bit off, but it actually should pass through these atoms, right? These atoms. Now I would draw another. If you look at this, so this is two parallel triple one planes. This is your origin. right? So it is intercepting x at 1, y at 1. Sorry, let's say it looks like, let's bring it to, this is your x, so this is your origin, so it's intercepting x at 1, y at 1, and z at 1. The same is true for this plane. Let me make it 2. So now it will be clear, right? Okay. So these are the two parallel triple one planes in a unit cell. Okay, if you want to draw a 110 plane, let's delete it and let's say 110. Right, and let's place it 1. So this is your 110 plane, right? It's actually intercepting x at 1, y at 1, and it's parallel to z. So this is your 110 plane. Clear? So what you need to do is you need to open your books and study directions and planes in detail. We will also discuss it in the next class, and then we will move forward. So thank you for today. Thank you for your time, and I'll see you in the next week, inshallah. If you have any question, you can comment in the Google Classroom. So I will try to answer it from there. Okay. Thank you.